My research looks at how the brain is different in individuals with dyslexia or reading impairments. Structural differences in the brain can occur in either the gray matter regions, which is what most people think of when they think of the brain, but it can also occur in the white matter pathways, or the fibers that connect the various gray matter regions. One key issue in the field is, how do we identify individuals with dyslexia? A number of neuroimaging studies fail to describe how they have identified individuals in this population. So for this study, individuals with dyslexia had two criteria that they had to meet. One, they had to have a history of reading and writing impairments growing up, but two, they also had to continue to show deficits in decoding, or the ability to sound out words into their individual sounds. So poor decoding for this study was defined as a score of 85 or lower on a non-word or pseudo-word reading task. I targeted 7 different white matter pathways that make up the reading network and their connected cortical regions. So I used a novel technique called bidirectional iterative parcellation to identify these particular pathways. What bidirectional iterative parcellation does is it takes an individual voxel, or you could think of a pixel in the image, and determines whether or not the next voxel, based on probabilistic tractography, is connected to and makes up this particular fiber pathway. Additionally, bidirectional iterative parcellation identifies the voxels that are directly connected to the pathway of interest. And it does this in both directions, going from one endpoint to the other endpoint and back again multiple times until what is left is the identified pathway of interest, as well as the connected cortical regions of interest. And fractional anisotropy is a particular measure of white matter integrity, with a higher value, or a value closer of 1, indicating increased integrity or greater integrity for a particular pathway. What I found was that individuals with increased white matter integrity, particularly in the A-slant, a frontal pathway, had lower readings on both pseudo-word reading and non-word reading. What this implicates is that individuals with dyslexia could be relying more heavily on this anterior pathway, as opposed to more language critical pathways that are in the posterior region and are known to be implicated with reading.